Okay. All right. So to cover, just to go over what we're going to cover in the two workshops, we've got another workshop on Docker planned for next week as well, and hopefully, well, by the end of this workshop, you should be really comfortable with what Docker is, all of the main Docker components, the Docker terminology, and be comfortable to be able to install it on your machines and go away and play with any images in the Docker repositories. Okay. By the end of the next workshop, you'll be able to create your own Docker images, be able to use the more advanced components of Docker, which will help you get your dev environments up in a flash. Okay. So those are my two goals for this. Today we'll be covering what Docker is. I know a lot of you guys use Vagrant, so we'll be covering some of the differences between Vagrant and Docker. The main Docker components, installation, and actually there are a lot of slides up to this point, so just bear with me on that. If you've got any questions, let me know. I'll try and speed through it, and then we'll go into actually how we start Docker, how we use it, how we use the commands, and how you can use it to actually run containers with different services. So that'll kind of be more of a demo, hands-on aspect of this. With the advanced workshop, we'll be going into Docker files, we'll be going into how it integrates with Bitbucket and how the Docker registry actually makes automated builds from that. We'll be going into some of the more complicated containers, so Nginx reverse proxy container, why we might use that, data-only containers, again, why we might use those. We'll be going into some of the more advanced Docker tool sets, so Docker Machine, Compose, Swarm, and then hopefully we'll have enough time to see how we would use this from a web dev team perspective and how easy it can be to develop, literally from scratch, through to getting stuff onto a test site. We'll cover some of the other topics like Docker security as well. The Docker file system I'll touch on today as well. And then because we're going into some of the other aspects of actually creating images for yourself, we'll cover some of the best practices involved there. So, Docker. What is it? So the tag phrase which you'll have seen pretty much everywhere is build, ship, and run any app from anywhere. And that's what the main, that is kind of the main thing that Docker is trying to achieve. Whatever you develop on your local machine is going to be exactly the same as what you see on the test sites, and then going forward, staging and production environments. So it uses Linux containers as its virtualization technology. We'll go into all of this in greater depth in a few slides' time. So Docker comprises of the Docker engine. The Docker engine is otherwise known as the Docker daemon. In order to communicate with the Docker engine, there is the Docker client. So it's a client-server application system. So you have the client, it sends and receives communication messages to the Docker daemon. The Docker daemon executes those. We have the Docker registry, which is used to store images. We have Docker machine, which can be used to create Docker engines on any host that you want. We have Docker Compose, which can be used to fire up a whole series of containers, which will then form your actual application as a whole. There is something called Docker Swarm, which can be used to manage clusters of containers. And Kitematic, and this is to do with Docker Client. So within Docker Client, you can either use CLI interface for that, or you can use a GUI interface, which is what Kitematic gives you. But you lose quite a lot of visibility of what actually is happening. So we're all developers here. I don't think this is something which you guys should use to begin with, just so that you actually get familiar with what Docker is doing and understand it. So, I was going to do some images for this. But kind of going back to a few years ago, in terms of how you guys would develop, you would have an application, and generally speaking, one application would sit on one physical server. So, from there we kind of move to virtual machines, and then we'll get to containers. But what you generally have when you had one physical server, you're running your entire application stack. Let's say it was a new project and you started developing it and you got to the stage where you wanted to deploy it to production. You'd have to go to sysadmin guys and you'd ask them for a box, and maybe they've run out of physical boxes at that point, so then they make an order. It's quite costly getting a new physical box in. Finally, I don't know, a couple of weeks later the box arrives, then you have to deploy all of your main services running on it. The box itself might have lots of resources on it. Your application might only use a fraction of those resources. So ultimately, you'll have a lot of wasted resources on that box. If you wanted to scale that, again, very difficult. Maybe you'd have to get another physical box. Also, if you wanted to migrate your application to another box, that gave you a bunch of headache problems as well. And quite often, if you ordered your box, I don't know, with a certain provider, a vendor, you would then tie yourself, you would bind yourself to that specific vendor, unless you wanted to go through all the pain of actually migrating to a different one, which I know we've done recently. Not recently, we're trying to get through that with FastSaves, for example. So then along came virtual machines, and this was a great way of having one physical server, actually running hypervisor-based virtualization, which allowed you to run multiple applications on the same server. This was great as you could start using more resources that the box had to offer. It was definitely easier to scale because instead of having to order up new physical hardware, you could spawn out new applications. And that has led to, I think I left this out, that's led to virtual machines in the cloud, giving you rapid scalability, even to the level where, if the cloud provider actually detects that you're under stress on a particular application, it can fire up more virtual machine instances for you and share out the load that way. So, what are some of the problems that we have currently with that? So, each virtual machine still requires its own CPU, its own storage, and its own RAM. Each virtual machine runs its own entire guest operating system. So, at the end of the day, you've got one physical box that's got limited resources and hardware. If you've got virtual machines kind of running their own entire operating systems for no real benefit other than to run every service that you need on that virtual machine, that would consume a lot of additional resources. And another thing as well, unless you're using something like Vagrant to provision your virtual machines, then there's no way to absolutely guarantee complete portability. So what you've done in test or development is exactly the same as what you're doing in production. So, along came containers. And containers, this is not new technology. This Linux containers, I think they were added to the Linux kernel in 2008. So they've been around for a long time. And what they do really well is they allow multiple guest instances to run on the same host OS. So this is what Docker actually utilizes. So each container, when it gets spawned up, it's got a root file system, it's got processors, it's got its own internal memory, it's got its own network mapping, it's got its own it's got its own devices as well associated with it. So what are some of the differences between containers and virtual machines? So virtual machines, as we've discussed, they run on a separate guest OS. So whilst you'd have your host OS here, each virtual machine that's fired up gets fired up with its own guest OS, and each application has got its own binaries and libraries, all of which kind of contribute to additional size. So with containers, these run on the host OS, and they share the same kernel here with all of the other containers running on that. So you don't need to virtualize any hardware. You end up using less space because you don't have to install an entire operating system for each container. And ultimately, you can have more containers per virtual machine than you can have more containers per host OS than you can if you were using virtual machines. Another nice thing about containers is that they spin up really fast. We'll be able to see that in practice later. And they are completely portable. And again, this is something that I'll show you in practice. So one of the questions RS asked me yesterday was, what is the main difference between Docker and something like Vagrant? So really, Vagrant is the level up from Docker in terms of abstraction. You can't really compare the two directly. Vagrant is used, and I've not actually used Vagrant in a proper development capacity, but Vagrant, as far as I'm aware, is something that can be used to manage virtual machines. So it can be used to do that, and it can be used to configure virtual machines to however you want them to be configured. And you can also provision those virtual machines with certain services from startup. So I believe that's how SysDev use it, and Fleet as well. They'll have a Vagrant configuration file which will provision the box, provision the virtual machine, and they'll have a configuration with all the services they need running, and it'll execute them one by one until you've got your dev environment set up.
That's a quick question. Could you actually run Docker on a virtual machine?
Yes, you can.
So in other words, you don't have to tie it directly to the hardware.
Exactly, which is why it is very different. So
you can run it within a Vagrant machine?
Yes, you can, and you actually get Docker provisioning within Vagrant. So within Docker, we used to have something called boot to Docker, which was something the Docker kind of development progresses very, very fast. So this is not something that you guys will have to use at all now, but it's something that maybe 4 or 5 months ago we were using, and what that was on a Mac. A Mac is not the full distribution of Linux, so it doesn't have the kernel features to allow it to use Linux containers by default. So you actually have to install a virtual machine, and you would use boot to Docker to do that, to install a very lightweight version of Linux, and the Docker host would then be installed onto that. So Vagrant can almost be compared to something like boot to Docker. Nowadays we have something called Docker Machine, which I'll be showing you the basics of it. But Vagrant can be kind of almost compared to the top level of Docker, the thing that actually provisions the Docker hosts. So I think it's kind of unfair associating the two of them and trying to directly compare the two of them. So the Docker architecture, as we've mentioned, we have the Docker client, which communicates and sends messages to and from the Docker daemon. The Docker daemon runs on the host OS. And the Docker daemon is the thing that is responsible for building and running containers. Over here we've also got the registry, which can be Docker Hub. Think of it like GitHub. We'll again cover this in more detail. And this is used to store your images. So the Docker engine, aka the Docker daemon, this enables the containers to be built and run. This has to be running on the host machine. it can be installed on any hardware that you can think of. This uses the Linux kernel to create and manage containers. And what it actually does is it utilizes specifically the Linux kernel features of namespaces and control groups. So the namespaces, some of the ones that it uses are the PID namespace, which allows isolation of processes, the net namespace, which allows isolation of your network interfaces, IPC, which I'm not entirely sure what that does. There's the MNT namespace, which allows the mounts, and I think there's one other. We won't go into that at all. You've got the Docker client, which allows communication to go from yourself to the Docker daemon. And the nice thing is that the client and daemon can run on completely different hosts. So this is something we'll see in the advanced workshop, and it's something which Paul and I have been using with DigitalOcean. It's very cool. The client, as mentioned, it can be a CLI client or a GUI, which is Kitematic. I'm not going to show you anything to do with Kitematic today. So moving on to kind of components of Docker. Docker is really, you'll have heard it's comprised of images and containers. So images, you can think of them as your classes in PHP, for example. They provide a blueprint, but they don't actually have anything instantiated. Your objects, which are instantiated from your classes, and are actually things that you can do stuff with, you can think of your containers like those. So the images themselves, they are read-only. They are a template with which the Docker daemon creates containers from it. These images are built by you, or to begin with, you just use whatever's out there on the Docker registry. On the Docker registry, they have official images as well, and these are images which Docker actually, they've got a team of people kind of supporting those images and making sure that they're applying best practices to them, that they're applying security patches to those images as soon as they come out. So those official images, they're ones which you can trust. Otherwise, if you find another image, you can't be absolutely sure of its integrity and whether it'll do what it says it does. So images, these are the build component of Docker. So the containers, they're the run component, and containers can be based on one or more images. So this is kind of the layering aspect of Docker, and I'll move on to that in the next couple of slides. So the container holds everything needed for a specific service to run. The Docker registry, this is where we store all of our images. We use Docker Hub, which is the official registry. You can create your own private one if you want, but Docker Hub gives you the ability to have public or private repositories. We have... Sorry?
Where is it stored? Where is Docker Hub physically?
Where is it physically?
In the UK, in the US?
No, I don't know. I'd imagine... Well, it's the cloud, but where physically?
Which legal entity it falls under, whether it's the UK, European, or whether it's in the US?
Well, essentially, what you should never do, and this is one of the best practices, is make sure that any image that you have hosted on Docker Hub, make sure it's not something that you can't reproduce elsewhere. And that's what Docker files are used for. That's what the advanced workshop's for. So in other words, you should expect that Docker registry to go down, and if it goes down, you should still be able to recover and use your images. Okay? So yeah, think GitHub, Bitbucket, which you use for your code, obviously. Think of Docker Hub as that for your Docker images. So just briefly, how does a Docker image work? So the Docker Union file system, each image consists of a series of layers. So you'll have your base image, which might be an official image like CentOS 7 or Debian Wheezy. And when you create images subsequent to that, what Docker actually does is it layers on top of it the changes that you've made. So this actually means that, let's say I base an image from CentOS 7 and apply a particular service to that. That image then does not contain all of CentOS 7. It just contains the changes that you've applied to it. And it allows you to keep your images lightweight. And it also allows them to fire up really quickly, especially if you've got that single base image already on your computer. Then if you have 5 different services on 5 different images, they're just layers on top of those. And it's just those layers that need to apply.
Given the differences between the distros, what's the interface between the actual kernel and the hardware and the version you're running on
the interface
between... Are there limitations between what you can run on what hardware because of whether or not it exists in the kernel?
Well, so the kernel has to be a Linux container distro.
Right.
So on Mac, that's why we have to use boot to Docker.
Right.
If you're using something like Ubuntu straight off, then that's fine. Or CentOS, yeah, it's in that technology. If you're using Windows, again, you have to use a virtual machine. Okay. So moving on to some more kind of, we're getting to the demo part. What time is it? 1:30. So installation nowadays is really, really easy, unless you've got a rubbish internet connection. All you need to do is go into Docker and install Docker Toolbox. And what this does is it installs VirtualBox for you, if required. It installs Docker Machine, Docker Swarm, the Docker Engine, the Docker Client. Literally in one package, it installs everything for you. When we first started using this, it was all very much, the previous iteration to this was there was a shell script to run to get the Docker engine up. Then you would have to make sure you install boot to Docker yourself. It was all very individually. It's now really, really easy. Connection lost. Curses. So, Docker machine, and we'll cover this in greater length in the next workshop. But this allows you to create your Docker engine instances. So, to begin with, you'll just want to create something locally. You can use Docker machine to create hosts, Docker engines on hosts with drivers that are compatible with it. So I believe Amazon have a driver, DigitalOcean have a driver, which is why we're starting to use them. And it allows you to have the client running on your machine, and generally through the use of SSH keys allows you to send communications to those Docker hosts without having to do anything. It's amazing. So within VirtualBox, each driver's got its own options. Within VirtualBox, here are some of the options you might use. If you have a particular container which you know is going to need a lot of memory, then you can up the actual instance of Docker. This is actually the VirtualBox instance here. So if you know you're going to have lots of containers running on it, all consuming a lot of memory, that's when you would up your RAM here. If you've got a huge database, for example, and need to up your disk space, that's the option you'd use for that. So when you run this Docker machine create, it'll boot up VirtualBox for you, create a new virtual machine, and that virtual machine will have the Docker daemon running on it. And the only thing you need to do at that point, until you've got Docker up and running fully, is to get your Docker client communicating with that Docker daemon. And you do that by running a series of environment variable commands. We'll run this command on my machine, and you'll be able to see exactly what it does. It sets a bunch of environment parameters. Docker Hub. So Docker Hub's the registry. We'll just briefly cover some of these commands, then we'll launch kind of straight into some demos. Okay. So Docker Hub is your registry. From the command line, you can search that registry for any public repositories. You do that with Docker search something, so Docker search Redis, and it'll go through all the public repositories. It'll return you a list of them ordered by official repository first, and then stars. And stars are like your favorites. It's people going on saying, yeah, this repository is awesome, give it a tick. To pull an image from the repository, Docker pull. If you have any private repositories, which all of ours are, then you have to log in first with Docker login, and then you put your username and your password in, and then that allows you to pull down private repositories. So running a container. Once you've got your image on your computer, to fire up a container, it's very easy. The command is docker run. So if, let's say, we have the world stores beanstalk D image, it would be docker run world stores / beanstalk D. Quite often you'll want that container to run in the background rather than the foreground, because you'll just want to start up a bunch of containers and let them do their thing. So you would run this in detached mode, which is the -D flag. You can give your containers names, otherwise Docker decides on a completely random name for you, which is sometimes fun to see, but not always useful. The -P, so when images are built, you can tell images to expose certain ports. So for a MySQL image, you'd want to always expose port 3306, so that if another container was linking to it, it would have access to that port. -P will expose any of those ports to the host OS on a randomly assigned port. So if you ran a MySQL image which had within its template, its read-only template, exposed 3306, and you ran -P, it would then pick a port in your machine, I don't know, 5670, and map out 3306 to that port. So then, if you actually wanted to connect to that service directly from your host OS, you could run MySQL-u admin -P 5670. And that would connect you into the MySQL service running inside that container. If you actually want to be more specific than that, you can use -p, and that will map whatever you put in front of the colon to the port specified the other side of the colon. So if you wanted port 3307 :3306, that would map port 3307 on your local machine to the container's 3306 port.
I take it if you don't have any P's there, it just maps to the default.
If you don't have any P's, it won't map to your local machine. So what it will still do, because you've exposed 3306 in the image, is if you have other containers running linking to that, those containers will still be able to access the service through that port,
So container to container.
as long as, yeah, container to container. But those containers need to know the IP address of the other containers. They don't need to know that if you specify this link command. So that's we'll skip these two quickly. We'll come back to them. So --link. If you've got two containers.
Very quick question on the ports. Are you going to have an error if you try to map the same ports on the
Yes,
host machine?
it won't allow you to
two
start.
containers?
It won't allow you to start a new container. So let's say I've got my MySQL container running in under a container called Dave's MySQL, and I've got an Apache container, an Apache PHP container, which I want to link to that and use the MySQL service from that. So I would specify when running the Apache PHP container, --link equals Dave's MySQL : MySQL. Okay, and what that will do in the Apache PHP container, it'll actually create a host entry file pointing MySQL to the IP address, the internal IP address of the MySQL container. And that's how it can then utilize the MySQL container on the exposed ports. Okay.
So you're saying that by default, none of the containers have access to the host's network card and exit?
Well, network card, yes, they will all use the same network the network that you're connected to on your local machine, on your host.
So for outbound traffic, they can all talk out to the world, but for inbound traffic, only as their ports are exposed.
We've had some instance of this when setting up firewalls, so I want to make sure I get this right before I reply. What did we do? I think Docker actually sets up its own IP tables rules. So this is something that we'll chat about in the next workshop. But Docker actually exposes, I think it maps out certain IP table rules which allow it to communicate out.
Yeah.
And then how did we get around that? Can you remember, Paul?
The bit I'm always worried about is that you actually leak into the real world with test data and things like that.
No. So that's we've overcome that by using the Nginx reverse proxy container.
Right.
So we actually block all traffic so all the traffic going through to a specific host will go through port 80, because it's HTTP traffic. All of that traffic will be routed to one container. And that container's got itself mapped to 8080 here. Okay, so all HTTP traffic goes to that single container. That's a reverse proxy container. And within that is the denial of service to anything other than certain IP addresses. So I think when we actually tried to set up the IP tables rules for it, even though we were dropping all traffic, Docker itself, whenever it was starting, was creating paths out through that. So you did find a way of actually preventing that.
This is in a virtual box environment, yeah? Is that what
No.
We were running it actually on a Linux host with DigitalOcean,
So there's
in a
no
virtual box environment. You map and you can set your own lanes up within it, so you can isolate
this is it's regardless of that. So the -v flag that allows you to mount directories from your local machine through to the container mount system. And that's useful for when you've got Apache PHP containers, which you want to develop locally, but you want your code mounted within the container so that you can actually get the service up and running. It's also, it could be used for things like MySQL data or Redis data. Or logs, lots of uses for this. And then finally, the environment flag. Some images come with the ability for you to change their behavior when you actually run a container, and that's what you would use the -e flag for. So for example, one of the images that we have set up is the world source Apache PHP container, and if we put enable_xdebug equals true as an environment variable there, then it will enable xdebug for us. Very simple. If we don't put that, then it won't be enabled. So other frequently can use Docker commands, and we will probably use a lot of these in the demo. Docker start. So if you've got a stopped container, Docker start will start that again. A container, we've got that there. So Docker stop is used to stop an actively running container, and it's Docker start either container name or Docker start container ID. Okay. Docker remove removes a stopped container. Container has to be stopped for that. If you specify the -v flag, then you will remove any mounted volumes associated with that container that was used at runtime. So that's quite important to do if you don't want to have if you don't want to have your disk space grow exponentially without any particular reason. Otherwise, it just leaves the mount files there. Docker PS allows you to analyze the containers that are running, and Docker PS-A allows you to see not only the containers that are running, but also the ones that are stopped. Docker logs allows you to see the standard output that a container has written, and that can be useful if you have any problems with the container. You're not sure why it's bombing out or something like that. Docker inspect is used to see the actual mount system of the container, any port mappings. It gives you a lot of information on the container itself. Docker images lists the images that you have currently on your host operating system, which you've pulled from Docker Hub or wherever you get them from. Docker RMI removes images, and Docker exec allows you to execute commands within a container. So the -I flag, that binds container to standard input, I think, or allows a standard input to be, well.
I always think of it as like interactive.
Yeah.
But it doesn't actually do that.
The -T is it opens a pseudo terminal for you. So what we will do is we shall start from scratch. And actually, these are kind of the last slides. So we'll spend the next 20 minutes or so actually kind of going from scratch and running some containers. So I need to stop this. So I have not installed, no, I have just installed Docker Machine on this. So this is a completely empty, completely from scratch machine here. So this is that large enough as well? Make it a bit, yeah? Okay, so this is what you will get once you've installed the Docker toolbox. You'll come onto your command line and you'll be able to type Docker Machine ls, and that will list out any machines, any Docker hosts that your machine is aware of. So in order to create a Docker host, as we saw, we use Docker Machine create, and we'll specify the driver virtualbox, and we'll call this my dev box. So this generally only has to be done once. If you're on a CentOS or a Ubuntu system, you obviously don't have to do this because Docker will run natively. But what this is doing is it's starting VirtualBox, it's assigning SSH keys to it, and after that, once it's up, this will start with all of the default options as well. I think it's 1 gig of memory, or half a gig of memory by default. So this is my nice fast computer.
Very fast.
Yeah.
Amazing. Very cool.
So once this is done, we can then see, typing the same command, Docker Machine ls, we've got VirtualBox up and running on that specific IP. So I can say IP dev, and that'll give me the IP address of VirtualBox running. Okay, so any containers that are started, I have to access those through this IP address. If you've not had to install the virtual machine, so if you're on CentOS or Ubuntu, you can just do that through the localhost, 127.0.0.1. So at this point, if I try and run Docker PS to see what containers I have running, it should have kind of kicked me out, but that's because I've actually set up my environment already. So do you remember I said you have to tell Docker client to be able to talk with the Docker daemon that you've got associated? So you generally do that by running Docker Machine and dev, and you can see here, these are the commands that it'll run. And this is telling Docker what the host is to communicate with. So I've already run these on my machine, but in order to run them, all you need to do is type in eval of that statement. And then when you type Docker PS, you get your list of containers, which is nothing at the moment because we're from scratch. If we have a look at the images on our machine, again, nothing. We are completely bare bones here. Okay? So we'll first have a look at Docker Hub. So the command to actually find any images was docker search, and I don't know, think of something that you might want to put into a service. Nginx, okay. So if I do a docker search Nginx, you'll see here at the top we've got the official build of Nginx, and it's got a lot of stars associated with it. And then we've got a reverse proxy image, we've got an Nginx plus PHP FPM image, and a bunch of other images down there.
Second boss is really good.
Sorry? The second last. Marianne, can you read that?
Where was that you?
Okay, so what we're going to do is we are going to search for standard CentOS. Okay, so doc search CentOS. We've got the official build here, and we are going to do a pull of CentOS 6. So the Docker Hub, it's got a standard for tagging images. So let's say you actually have an application build within the images, you can tag it with your release versions, and that's how you would actually release it. So if we do a Docker pull of CentOS 6, we can see it's now going to pull down the image onto my computer. That's all it's going to do. From this point, there's still nothing running.
How would that work with Ubuntu and its double dot? Would you type in pull Ubuntu 14.04?
Yeah, exactly.
So
14.
whatever the
Yeah. So once that's pulling down, we can actually have a look here at Docker Hub. So I'm logged in as David Simon Ward. You can see I've got no images there. If I move to our World Stores account, which is our team World Stores account, you can see we've got a bunch of images which we've created and are in use fairly regularly. So we've got the MySQL image, which obviously fires up MySQL service, Redis, Apache PHP. We've also got images for Redis clustering, MySQL Fabric HA. I think that was Mike actually. Got an image for Beanstalk, which will fire up your Beanstalk daemon service for you, Percona extra DB cluster, the Nginx reverse proxy, which is very useful, and Cubase. Okay, so we've got, if we go to Docker images, you can see now we've got our CentOS 6 image here. And what we can do with that is we can do a Docker run CentOS : 6, and the command we will issue will be bin echo, and we'll say hello workshop people. So what this will do very, very quickly, from that image, it'll fire up a container, it'll execute that command that I've run. There you go, hello workshop people. And if we run docker ps, we can see there's no container there. And that's because containers only exist for the duration of the command that is running in them. Okay, so as soon as I hit enter there, it fired up a container with CentOS 6 running in it. It executed the echo hello workshop people command. It finished, and so it shut itself down. So if I actually use the ps-a, which shows you all your containers, whether they're running or not, you can see we've got the CentOS 6 container here, and that it exited 32 seconds ago. So the next thing we'll do is we will run this CentOS 6 image, and we'll say I just want to run the bash prompt from that. Okay, so now you can see we are actually inside the container, and if I do a docker, so that has happened because I do not have my environment set. So within this new terminal that I've created, this Docker client doesn't know which Docker host to talk to. So that's actually what should have happened when I demonstrated it the first time. So if I have a look here, and then you can see it's not active. You see there's no star there. So if I run docker env dev, and then I take this command, and now if I run the ls again, you can see it's active. Okay, so now docker ps shows me what processes are currently running. We've got that CentOS machine and it's still up, okay, because I'm still inside it there. As soon as I exit this, this will then show as being exited. So things I can do, I can have a look at the file system. I can remove lib home etc. Better make sure it's the container rather than my computer. Okay, so I can't remove it, but yeah, it's removed lib, it's removed home. What else should we remove? Serve, dev. Yeah. We can completely screw up like the internals of the operating system. So now we've basically got a container here which would not be able to operate. But it's okay, because it's a container. So we just exit it. If we have a look here, you can see we've got 2 containers. This one's exited 3 seconds ago. And it's fine, I can just fire up a new container and there I've got everything back again. So that's really nice and cool, a cool thing about containers. I'll briefly now show you how you can edit containers and push those up to the Docker registry and then bring them back down for reuse. Now this is something which, just take it as a bit of information, it's not something I've ever done. And the reason for that is because when you do this, you start to lose track of how your image was built. And that is something where if the registry goes down, then you're completely stuffed. So this is not something to generally do, but it's something to know that you can do. So I will create a text file in the root, and I will exit this. And this was, you can see the container ID there, but I can also see the container ID here. And you can also see the container name. So drunk noise is the one that Docker's decided to assign this particular container. Romantic Tesla, focused Saha. Those are some of the other ones. What we'll do, we'll just clear up these old ones as well to make it easier to see. So we'll do docker remove ID, and here I'll use the name. So docker remove this. You can also, by the way, guys, you can set up your own aliases like this. And I might start using these in this demonstration, but you know, for your frequently used commands, you don't want to have to type them out the entire time. So I can just do DP and that, or DPA. That gives me, you know, firstly, this first one is a kind of prettified Docker process, and the second one is everything. So I've made that change to that initial container, and I've added a file, which was dave.txt, into the root of it. If I do a docker diff of that container, you can see it shows me, like a git diff would, it shows me what has actually changed from that container from its original instantiation. So from this, let's say it was a change I really wanted to make. Maybe I don't know, installed Vim on it, or maybe I've put a complete repository on there. It could be anything. You can then do a docker commit 1A to B, which is the container ID, and I will commit it to my repository called world stores test. And here, this is the point you could tag it. So you could say 1.0 there. Otherwise, it goes in as latest. Okay, so that's committed, which is great. It's still not on Docker Hub here. So it's still empty. So then I can do a docker push 1A to B. No. So then you can look at your images, Docker images. And now all of a sudden, from CentOS 6, I've got that committed image, David Simon Ward WS test. Yeah. So it's the image you want to push, not the container. So you would do a docker push of this image ID, or you could do a docker push David Simon Ward / WS test : 1.0. So if I do that, Let's try this. Okay, looks like you need to refer to it properly rather than using the image ID. So this now should be sending the image up to Docker Hub for you. And once that's completed, we should be able to see it in Docker Hub. And what we'll then be able to see is when I remove that image on my computer, so let's say you started from scratch, let's say you started on a completely different computer, you could then pull in that David Simon Award /WS test, and it would have that dave.txt file as part of it. Okay, so we'll come back to this because I wanted to show you some other stuff. So what we'll do now is we'll start showing some of the linking and the port exposition. So I will pull down, firstly I'll log into Docker, because if I do a search for world stores beanstalk D, again as well, this eval command, you can, to make it so that you don't have to put that in every blooming time, you can put that into your bash startup. So you see at the bottom here, you can, this is Z shell if you guys use Z shell, but you can just paste in that command there, and every time a shell starts up now, there, it automatically connects to the right Docker host. So if I do a Docker search for world stores beanstalk D, nothing is shown because it's a private repository. So in order to access these, you need to set up your own accounts, and then I'll link them to our World Stores team account and do a Docker login, David Simon Ward. I've already logged in on this machine, but you'd put in your username, your password, and your email address there, and it'll tell you login succeeded, which is great. And then you can do a Docker pull world stores /beanstalk D. And this will pull down the beanstalk D image onto my machine. Hopefully faster than it's pushing it. So what we'll do then is we will fire up beanstalk D in its own container, and we will then grab a copy of the beanstalk console, which is something that we used to have to insert into our SKU-based code and actually have running as part of central admin, for example. But using something like this, you could actually just use Docker containers to fire up that maintained version of the beanstalk console and have it completely running from Docker instead of having it in your code, which is great. So we've got the beanstalk D service. So if we go to Docker images, we can see world source beanstalk D latest is there. And to fire this up, you do docker run -d because you want it to run in the background. We'll give it a name, call it bean service, and we'll say docker world source beanstalk D. Okay. So you see that's running detached mode. It's running in the background. You can see it's still up there. It's been up for 4 seconds, which is great. With services that are running, you can actually connect to them. And to do that, that's what you use docker exec for. So docker exec -i-t, the container ID, and then we want to run bash. So now I'm inside my beanstalk service, and if I check out the processes running inside that, I can see beanstalk is up on port 11300, which is great. So the next thing I want to do is, at the moment that container's running. I have visibility of that here, but I have no way of actually seeing that beanstalk service in a console. So what I'm going to do is I'm going to search for a beanstalk image, something that someone else has already used, or something that someone else has already created. And there's one in particular I'm looking for, and it's this one because I know it works.
0 stars.
With 0 stars, yeah, maybe I should star it. This is the so this is we have a Beanstalk console running for central admin. I don't know if Fleet of One, I know SysDev probably have some Beanstalk consoles as well. This is the exact same GitHub code. This is the guy who created the GitHub code for that Beanstalk console. So if I do a Docker pull of that, if you do a Docker run as well of an image which you don't have on your machine, it'll pull it down first and then it'll run it as well. Okay, so this is pulling down the Beanstalk console, and you can see at the top there that push has just finished. So you can see there I've got my WS test repository here, and details-wise, it's not going to have very much. If you go into our world source repositories, they've got a plethora of information on how to use them, how to build them. These are all done via automated builds, so I'll go through this in the next workshop. So let's go back. And now that we've got, whilst we wait for this other image to download, now that we've got my image pushed up to the repository, I can delete it from here. So docker remove image, that ID. And you can see that image has now disappeared from my machine. So if I run the docker run CentOS 6 command again, oops, and I go into the bash of that, you can see Dave's not there because this is a brand new container from CentOS. If I do a pull of David Simon Ward WS test colon 1.0, then it'll pull down that image, and you can see it didn't need to pull down the CentOS 6 image again because it already has that. So all it's doing is it's pulling down the changes on top of that, which is why that was so quick. And then if I do the exact same command we did here, but replace CentOS 6 for David Simon Ward, WS test colon 1.0, you can see my dave.txt is right there where we left it. Okay. Generally though, as I said, not the right way of doing things, but is good to know. So we've got our Beanstalk console here, and what we're going to do is we're going to run that. And we're going to, and I've been using this with the reverse proxy container, so I haven't actually done it this way for a long time, but we'll see. So what we're going to do is, firstly, we're going to, let's check out, we've got our running container here, bean service, right? And that's the name of that container. So firstly, we're going to link bean service to, we'll just call it Beanstalk. Okay. So what that's going to do within this Beanstalk console, it's going to set up a host mapping from the bean service that's running to a host entry called Beanstalk. That's all it's going to do. Actually, should we call it? We'll just call it Beanstalk. And then I'm kind of hoping this has got some form of Apache running on it as well. So I'm going to take a guess and say that, actually we're going 9080. So I'm going to take a guess and say that it's exposed port 80, and I'm going to map that to 9080 on my machine. And I'm going to run it in daemon mode in the background. So we shall see what happens. So this is kind of looking good. The container's up. Usually, if something's wrong, then if something's wrong with you running a container, then it'll exit pretty much immediately. So the fact that it's up is a good thing. I can actually inspect the logs for that container, and nothing seems to be untowards there. It's executed Apache D in the foreground. So what I'll do, I'll go into this. That's the wrong IP address, isn't it? Oh. Docker machine IP dev. So that's the IP I need. And we're going to go to port 9080. All being well, we might see a Beanstalk console here. Amazing. Okay, so this is the Beanstalk console running. And at the moment, we don't have any servers here. Does this look familiar to anyone? Everyone who's used Central Admin must have seen this, right? Yeah? Resounding yes.
No,
Mike, does this look familiar to you?
no, no.
He's gone to sleep. Okay.
Who's Mike?
So
Is Mike?
at the moment, we've got nothing added to there. And if I try and add localhost, for example, nothing happens because it can't detect it. So you can see I've tried to add localhost, but I can't actually go into it because it can't connect to that service, so there's nothing running there. But if I actually put the host as the name that we map the bean service to, the host's entry, and if I click add server, all being well, this will then, oh, is it Beanstalk D?
Yeah.
Okay, well that's good, because that didn't work. So Beanstalk D. Fingers crossed here. So this will then, great, you can see that. So what it's done is this container that's running the console, it's got a host entry file, Beanstalk D maps to a container IP address. And that's how it can then pick up that service, and we've got Beanstalk running like that. To show you what happens if I bring down the Beanstalk service, for example, docker stop bean service, and it generally takes like 2 or 3 seconds to actually stop a container that's running. So that's the Beanstalk service stopped. So if I check it out here, bean service exited 4 seconds ago. If I go back here, refresh that page, the server's unavailable. Can bring it back, no problems. There, just like that. So the final thing I'll show you is mounting volumes. So one of the things I've got here in my sites directory is a battleships test. So if I go into battleships, we've got this guy called Dilip, and we've got his entire battleships test there. What I ideally want to be able to do is to view that in the browser without having to have Apache PHP running locally on my machine, and you can do that through Docker. So you can either use one of our own Apache PHP images, or you can use something that's been built for you. So I think I found an Nginx one, which is quite cool. So we'll do a Docker search for Nginx. This Rich Harvey one, this one just about works. And I need to remember, so with all of these, you need to know, for example, because Rich Harvey has created this Nginx container, he's in his sites enabled directory and the configuration for Nginx that he's put in, he's put it in the standard directory of user share. Yeah, I've actually got it here. User share Nginx HTML. So you need to know that kind of information in order to in order to use it, and that is what the Docker Hub is very good for. So if I actually search Docker Hub for this particular repository, you can see it's there, and you can see hopefully that here is an example of how you run it. So you see your code directory would be mapped to user share nginx HTML. Okay. So what I'll do, Docker run, name of the container is going to be called Battleships. We're going to map 8080 on our machine to port 80 on the container. We are going to put the Battleships dilip code into the user share nginx HTML, going to run it in the background, and this is the image that we're going to use. So if I hit that, so you can see I hadn't done a Docker pull on that image before, so it's going up to the repository, it's fetching it for me, it's going to bring it all down, and once it's done that, it's going to run the container. And that will probably be it. So here, if I go to this and go 8080 and then public index, you can see at the moment web page is not available. And whilst this is downloading, has anyone got any questions? Which I'm not going to answer in the next workshop. Excellent.
Why would you do a Docker pull? If you don't
Actually, Mike has a question.
Yeah? I can't see you, Mike, so you have to speak up.
He's using the chat. So basically what he asked is, what are the benefits of Docker machine over boot to Docker?
What are the benefits of Docker machine over boot to Docker?
Yeah.
So the main benefits are that Docker machine can allow you to fire up Docker host instances on any number of drivers. So that's something that boot to Docker doesn't give you. So there are the compatible drivers, which I mentioned. We can have a look, and Docker machine drivers. So, so you can actually utilize them with any of these cloud providers. So there's DigitalOcean there. It doesn't have the list here. I've only used it with DigitalOcean, but I'm sure Amazon Web Services is one. I think, what's the Microsoft cloud? Azure, that's another one. Here you go. Amazon Web Services, Microsoft Azure, DigitalOcean, Exascale. I'm not going to read them all out, but this gives you an idea of what Docker machine supports, and this is just not possible with boot to Docker. Hope that answers your question, Mike. Good.
Say something you've done.
The other advantage as well is that you can use Docker Swarm with Docker Machine, which allows you to fire up clusters of Docker hosts on any of these drivers. Oh, look at that. Battleship game's up. I haven't even done anything. That's amazing. So you can see pull completed. Downloaded it, ran it. I've now got Battleships running with Nginx and PHP. Yeah. Yes, because his code maps it back to 8080. So I remember this. I had to go in and change his code.
Don't need them.
Yeah.
So when you did a run, it automatically pulled the window, doesn't it?
Yeah.
So why would you do it?
Why would you do a pull? Is that what you were asking, Mike, or is that what?
That's what I was asking you before, just as a...
Yeah, why would you do a pull?
If you've already got an image.
Yeah.
It doesn't pull it when you do a run.
It's not necessary. You can, if you know what you're going to run. Doing a pull is actually there is one good reason why you would do a pull. is if you have an image already on your machine, let's say the world stores MySQL image, and if some of us have been making updates to that image is not going to change on your machine until you do a Docker pull of it. So I can check out my existing images here, and I can do a Docker pull on world stores beanstalk D, and it'll actually go back up to the repository, see if anything's changed, see if there are any other tags involved, and pull those down. Okay?
If you do an RM, I think it removes the image and pulls it again. I'm not sure.
If you do an RM on...
Docker run -r.
If you do... Oh, you think it removes the image as well?
I think it.
Okay. I'll be covering that in the next.
So this beanstalk image that you've put in world stores repository. So you've downloaded an original image and then you've modified it?
No, this is completely RN. So because we use CentOS 6.5 on all of our production boxes, and because there don't seem to be many people in the community that use CentOS 6.5, most of these images I had to build completely from scratch, which was great. So in answer to your question, this is something that isn't based on anyone else's image. This is something completely custom to us. So if we have a look at
In other words, you know exactly what's in it.
Yeah. So all of them are based from the CentOS 6.5 official image, and we'll be covering more of this in the next workshop. But this is an example of a Docker file. So this can be used to create images. And you can see we go from CentOS 6, we run a series of commands, we expose a bunch of ports, we make sure that our bin log is mounted as a default volume, and we have a series of commands added. So if you noticed, when I actually ran the world stores beanstalk image, you see I didn't put any commands after the image name. If I do put commands, then I would overwrite what's in the Docker file. But because this image has been built with this command in it, this is what will get executed by default. Okay? So we'll cover this in more detail at a later point, but that's the Battleships game up and running. And that is Docker Basics. So hopefully you guys can all go away and get it installed on your machines, whether it's Windows, whether it's Mac, whether it's Ubuntu, doesn't matter what it is, go away and install it. And if you want to create Docker accounts for yourself on Docker Hub, great, go for it, and give me your account names and I'll link you to the WorldSource team account. And in the next workshop, we'll see how you can really quickly fire up multiple containers linked together using Docker Compose, which is really useful for firing up development environments very, very quickly. I can't remember what else we'll be covering. We'll cover the Docker files, how you go about creating those. We'll talk about how we keep those under version control within Bitbucket, how Docker Hub connects to that and builds images automatically from a post-commit hook. We'll talk about the reverse proxy container, what it can do, because at the moment, this is a bit of a problem for us. The fact that we have to put the IP address of the VirtualBox machine in there. We'll talk about running data, so MySQL data or Redis data or code, web code data in their own containers, which is very cool. And yeah, we'll talk a bit about security and how we'll probably end up using this from a web dev side of things, and how easy it should be to develop code and get it onto a test server in a matter of minutes. Okay?
Great.